Hello everyone, welcome to my channel. So in this video, in our sorting techniques, we will talk about bubble sort. So bubble sort is a type of sorting algorithm that basically works by repeatedly swapping the adjacent elements if they are in the wrong order. So this algorithm is works by comparing the adjacent elements, whether the adjacent element is large or not with the previous one. If yes, then it will swap the elements. So here we basically traverse from left to right and compare each and every adjacent elements, and the higher one is placed at the right side. We compare it till we got the highest element and we place it at the right hand side or at the end. So like the bubble sort, it means bubble, so we have to pick the largest bubble in our array, largest element in the array, compare it with the adjacent element and move it to the right hand side, shift it to the right hand side. So in this way the largest element is moved to the rightmost end at first. This process is then continued to find the second largest and place it, and so on until the data is sorted. So in this way we will do the bubble sort. Also this algorithm is not suitable for large data set, as its average and worst case time complexity is quite high, because we are comparing it with each and every adjacent element. So in case of large data set, it will not be feasible to compare each and every element with that much amount of large data set. So let's start, and let's first try and do the dry run of this algorithm. So with the dry run algorithm, let's first write an array. So my array here is 10, 1, 7, 6, 14 and 9. Okay, and let me also write the index of all these. So in bubble sort, we usually do the bubble sort by comparing the adjacent element. Okay, so we do the comparison, or I would say we do specific round. So in each round we pick the largest element. So let's suppose we have 1 2 3 4 5. So total our n here is 5. So we will do n minus 1 equal to 4 rounds. Okay, and in each round we will pick our largest element. So let's suppose in round 1 I will be checking if my 10 is greater than my 0th index is greater than let me just write this index so it will be better for you guys. If my 0th index is greater than the first index, is 10 is greater than the 1? If yes, I will swap, but in this case it's not. Next I will be comparing if my 10 is greater than 7. Okay, just sorry, yeah, I thought it would be the opposite. So yes, 10 is greater than the 1, so I will do the swapping. So here I will put n and 7 at my first, then 6 4 9. Now I will compare in now I will compare here. Is my 10 greater than 7? Yes, 10 is greater. Then I will put 7 here, 10 here, 6 4 9. Now next, is my 10 greater than 6? Yes, it is. Then do swap. So 1 7 6 10 4 9. Is my 10 greater than 4? Yes, it is. Do swap. So in this way I will be comparing 10 with 4, then do swapping, then it 9. So at last, after round 1 I will be getting my array as this. So here we can completely see that the largest element first largest element of the array is placed at the end. So by comparing it with the adjacent elements, we traversed it from left to right and we place the largest element at the right hand side. Okay, now this is the round 1. Next, in round 2, I will be comparing and finding out my second largest element. Okay, so now I will be picking again, but now my index is 1. Earlier I have 0. So in round 2 also, by each and every round I will be incrementing the index of my loop. Okay, so here I will be pick if my 7 is greater than 6. Yes, do the swapping. So now array looks like 7, 4, 9 and 10. And also this part I will only compare it till this, because my last is already sorted. Okay, this part is sorted. So 6 is smaller, so I have swapped. Now 7 is smaller. Yes, I will swap. Is 7 is smaller than 9? No, so I will not swap. But I got my 9 as my second largest here. Okay, so I will place my 4 here, 7 here, 9 here, 10 here. Okay, now in round 3 I will pick my third largest element. Okay, so I will now check if my 7 not 7, if my 4 is greater than 7. No, but here we can see our 4 is smaller than the 6. So what we will be doing here, I will be swapping this 4. Okay, or I've just missed a trick here. Okay, I think I have written 14 over. Yes, but 4 I have assumed. Okay, not an issue. We will also see this case. So our 3 elements are sorted. Okay, up to this part is sorted. We have sorted. So now I can see my 6 is placed before 4. What we will do, we will again run our loop. Now I will check, is 1 greater than 6? No. I will increment my loop. I will increment the index. Now I will check, is my 6 greater than 4? Yes. Then do the swapping. So now my array looks like 1, 4, 6, 7, 9, 10. Now in my round 4, I again check if any element is smaller. No, then no swap. Then in round 5, I will again do, if my elements are smaller, then no swapping. So what we are doing here, we are doing the rounds, we are doing the comparisons. Okay, and for this we are going to run 2 loops. So first my loop will be from I 0 to n minus 1, because I have taken I as 0. If I have to take I as 1, then I will running it till n. My n in this case is 6, so I will be running till 0 to 5, n minus 1. So here we have 0, 1, 2, 3, 4, 5, and our unsorted array looks like this. So to conclude, let me just write the unsorted as 10, 1, 7, 6, 4, 9. 10, 1, 7, 6, 4, 9. Now I will assume it as 4, though it was 14, but let's assume it as 4. Okay, this is 1. Okay, so this was the unsorted array and we have to perform the rounds. So after performing rounds, our array looks like 1, 4, 6 and 7, 9, 10. Okay, so here we are going to first run a loop till 0 to n minus 1, I equal to 0. So we can see here, like whenever I run this loop, I usually compare with 0 to this. Okay, but I can see on every round my last element is going to be sorted, so I have to run another loop, but till I. Okay, till, like you can see, first in my ith loop my 0 or my first element is sorted, then in 1 two element is sorted, then in second, then three. So we can see a loop. I think you have understood. So this type of condition is forming. So for next, not the I. So for next loop, we are going to run it from j equal to 1 to n minus 1, or we can run it like j equal to 0 to n minus I minus 1. Why? Because in every iteration we are going to minus the last element because we have a sorted element. Okay, so in each iteration we are going to have a sorted element, and we are going to compare this 0 second element with n length minus I minus 1. Okay, so now let's see the program and see what I was talking about. So let's start the code. Okay, so let's start the program. So let me write an array here in main method. So in main we will be writing our array. We can either take the same array or a different one. Let's take a different one. Let me put 2 at last, smallest one, and I will be running a loop here from I equal to 0 to n minus 1, or I would say array dot length minus 1, and then incrementing the I. Inside this I will be running another loop with j equal to 0 and j less than array dot length minus I minus 1 and j plus plus. Okay, inside this we will do our comparison. Okay, so first, if array of j is greater than array of j plus 1, then we will make a swap. So I will place array of j means 0 in temp, and in array of j I will put j plus 1. First value means I will put, and in temp or in array of j plus 1 I will write temp. Okay, now let's just run this. Let me just print this. After this, int I array and system dot out dot print I. Okay, so let's just run this program. Okay, we can see our array is sorted, but there was a case, like in round 3 our array was sorted till round 3, but I have to run round 4, round 5. So there was a way like we can just reduce the time complexity. I would say I don't have to run those cases. So for that I will just create a flag as boolean swap data, and I will put this flag value as false. Now in my case, if I am doing the swapping, if this value is true, then I will be writing swap data is true. Otherwise what I will be doing, if swap data is false, then I will simply write this break. Okay, so now what will happen is, suppose in case this comparison is not true, then it will not enter inside the loop, and it will not the loop inside the comparison, and it will not do that comparison. Also, let me write this unsorted one also for a better understanding here, and just let me do one more print statement. unsorted one and sorted one also. Okay, so we have the unsorted one and sorted one. Okay, now the thing that I was telling you guys, let me just explain you. So in that case, what I was telling you, let's suppose in the first case, we have our n here is 6. Okay, here we have our n is 6. Now I'm going to run this array, so I will be comparing if my 5 greater than 8, no, 5 greater than 1, yes. So I will do this swapping. So now I will do this swapping and I will just put this for better. Let me just also do the debug. Okay, I have to put some breakpoints. Okay, now let's start the debug. Okay, so now we can see our array here as 6 array length, and now my I is 0 and j is okay, j is also 0. So in this comparison, I'll be comparing 0 is greater than 1, then no, then I will just increment my j. Now I have my I at 0 only, so 5 is going to be compared with second index. Yes, it is small, so we can see now the changes. So our array is swapped. Okay, now again I'm going to compare. Now my comparison will be is j is here 2, 0, 1, 2 is 8 greater than 2 plus 1, 6. Yes, then I will also do the swapping. So we swapped here. Now again it is compared to 9, no, then I will increment the loop. Now my 9 will be compared, so we can see 9 is placed at the end. So here what we have learned, my first 0, initially I have 5. Okay, my array looks like this: 5, 1, 8. Okay, and I think 6 was there, 2 was there, and odd 9 was there, or 2, something like that. Okay, 5, 1, 8. Let me just check. 5, 8, 1, 6, 9, 2. Okay, so it was like this: 5, 8, 1, 6, 9, 2. After the comparison, what I have done, j equal to 0 and j plus 1. So 0 compared with 1. So 5 compared with 8 greater, no, 5 is not greater than, then increment j. Now my j becomes 1 and j plus 1 is 2. So 8 greater than 2, yes it is. Then my array looks like this: 5, 1, 8, 6, 9, 2. Now 2 greater than 3, second index is 8, 8, yes it was. So now it becomes like this. Okay, 5, 1, 6, 8, 9, 2. Is my 8 greater than 9? Third index 0, 1, 2, 3 greater than 9? No, so skip. Now 9 greater than 2, 4 greater than 5, yes. So it becomes 5, 1, 6, 8, 9, 2. Okay, but remember the condition that I told you about. Array dot length is 6. 6 minus 0 minus 1 is 5. So I have to compare it till 5. But in the next iteration, my I will become 1. So I have to run it till 4. So now I will, at the end of this, 1, 5, 6, 8, 2, 9, I will not compare this last. So 0, 1, 2, 3, 4. I will compare it till 4. Now let's see the thing that I told you. Now I compared swap data is, now you can see I is 0 here. It will increment I to 1. next. So now I will compare it till 4 only. Okay, so in this way we do the bubble sort, and we resolve the sorting using the bubble sort. So that's it for today, guys. Thank you.